Today we will see how to design earthing ground grid with the help of ETAP software using IEEE standard, IEEE80 standard. First of all, let's draw a single line diagram. Let's put one lump load here. One induction motor and another lump load. Okay, this is a simple single line diagram of an electrical network. Let's define the values of each of the equipments. Suppose this is 10 megawatt 11 kV generation voltage and impedance, typical data. Let's click OK. Suppose this is 0.42 and rated MVA to 2 MVA, typical impedance. Okay, this is 800 kilowatt. Okay, let's define the lump load here. Suppose 0.4 MVA. Okay, 0.3. Okay, now we have defined the values of each of the equipments considered for this simple electrical network. First of all, let's run the load flow calculation so that we can check everything is okay. Okay, this is 100% bus voltage and power is flowing. Active power is 99.8%. Okay, let's run a short circuit. Let's create a fault at this 11 kV bus. Now let's run this short circuit study over here. Okay, see this is the short circuit value. If we see here, single line to ground fault. Okay, we can see this fault level is 5.171 kiloampere. This is required. This value we will use while designing the earth grid. So now let's go back to edit mode. Okay, for ground grid design we have to choose from here. See ground grid, just click here, select here. Sorry. Just drag and drop. Okay, just to identify in a better way, let's give a color. I'll prefer, okay, this color setting. Okay, now whatever we have run in short circuit calculation, we want to update this short circuit rating into our ground grid design calculation. So simply right click here. Okay, let's run once again. Okay, this is the fault current 5.171 kiloampere. Now let's right click here, update fault kiloampere. Okay, now you can see this fault type is line to ground fault at bus 1, and new value is 5.171 kiloampere, and X by R ratio is 9.66. So click here replace. Okay, this is the first step. We have selected this bus along with the short circuit rating, whatever we have obtained from the short circuit calculation. Now let's double click here. This is as per IEEE method. I will use this method. Click OK. Now this window is for ground grid system for grid 1. Here you can choose any one shape of your plant, whether it is rectangular shape or T shape, L shape, triangular shape. So for the simplicity I will choose this rectangular shape here and just drop here. Okay, okay, now this is the grid, preliminary grid over here. So just double click here. Okay, now you see we have to specify the grid size. Here grid size LX and LY value. Suppose LX is 50 meter and let it be there, and LY I want to change it, suppose 20 meter, and in X direction I want to change it 3, and this is 2. Okay, conductors depth of 0.5 meter. So this is the ground grid conductor. I want to design for 0.5 meter depth. You can change it also. Some in some projects I have seen this is 0.6 meter also. Okay, so let's check. Let's change this 0.6 meter size. You can choose the size of the conductors. Suppose 150 square mm, and type here you can select from the drop down list. So anything you can choose, and based on that you will see the material constants will change accordingly. This conductivity, alpha factor, k0 factor, so that resistivity, thermal capacity, so all these material related factors those will be changed. If you see this is changed now. And also additional feature, you can get the costing. You can calculate the cost over here, that how many conductors and how many rods are being used, and what is the cost dollar per meter it is there. So for me it is not required right now. Okay, let's go to the rods. Here number of rods, suppose I'm changing to 3. Diameter 2 centimeter, you can change it also, and length 10 meter. Okay, you can change this length also, suppose 6 meter, or in some projects I have seen the 3 meter also. Okay, this arrangement, let it be there. Rods throughout grid area. Type, this is the material we have already selected. For conductors, the same material we are using for the ground rods. Now click OK. Now you can see here, so 1 2 3 conductors, and this side 1 2 conductors. Okay, and from this figure you can see number of ground rods, 1 2 3. These are ground rods or electrodes. Okay, so before going to the case study, let us check the soil profile here. Just double click here. So now this dialog box will come here. You see the resistivity in ohm meter, 2500 material clean limestone. If I want to change it, suppose surface layer I want to change it in as a gravel depth 0.5 meter, you can change also 0.3 or 0.4 as per your requirement. Okay, now also you can change the top layer and lower layer also. So for the top layer, if I change it, suppose moist soil, and lower level, suppose wet organic soil. Based on this, you can see the resistivity in ohm meter, it is also changed. Okay, and this is the depth. So based on that, this depth and soil resistivity will be defined. Now click OK. Okay, now the grid is ready to calculate or to estimate. So okay, before that, okay, now click this ground grid study. Okay, now before ground grid calculation, we have to check the edit tab over here. Just click here and you can see reports and plots, auto display, summary and alert. Okay, these options, wait, yeah, you have two options as per IEEE 80. You see here method IEEE 80 2013 version. I am using the latest one, and as per this you can choose any one, 50 kg or 70 kg body weight. I am choosing here as 50 kg, ambient temperature 40 degrees centigrade. Okay, now fault duration you can change here as per the actual data of your project. TF, TC, that means fault clearing time, TS, shock duration. So these values you can change. By default it is 0.5 second, all three are 0.5 second. You can change as per your requirement. Now ground short circuit current. Ground short circuit current you can specify as per user specified, it's there, or you can pull out the data from short circuit study. If you click here, now you can see this value whatever we had seen earlier during our short circuit calculation. This value was single line to ground fault 5.171 kiloampere and XYR ratio as 9.66. Now click OK. Now let's run the ground grid calculation. Okay, earth grid. Okay, okay. Now what we can found that there are some errors. There are some error messages. What is that? The maximum touch voltage exceeds the tolerable limits. You see this calculated touch voltage is 3438.2 volt, whereas the tolerable touch voltage is 2054.3. So this calculated value is more than the tolerable value. That's why this is not recommended, or this is not expected. So this is the error. Okay, second error is the spacing between parallel conductors is smaller than 2.5 meter or is greater than 22.5 meter. Okay, let's close this one. Okay, so for this you can see this space was 50 meter. This space was 50 meter, 50 by 20. So we need to revise the spacing over here. You see 50 meter, this was 3 and this was 2. Now you can change here manually. You can change here manually this conductor data and number of rods over here, or you can do another thing. ETAP software has that feature that will be helpful. So let's close this dialog box. Here you can see optimized conductors, and this one optimized conductors and rods. So if you click over here, it will optimize the number of ground conductors and rods required, minimum number of grounding conductors and rods required to satisfy the calculation. Just click here. Now you can see tolerable voltage is 2054.3 and calculated value is 1890.1. So this is the recommendation. To achieve this, we have to use the optimal number of conductors in x direction 3 numbers and y direction 7 numbers, and optimal number of rods is 4 required. So these 3, 7 and 4, these are the required value to obtain the grid resistance of 0.951 ohm, and whereas the GPR will be 5066.9 volt. Okay, let's close this dialog box. Okay, now you can see you can change the values over here manually, either manually, or you can do one thing. Let's check what is that solution. Let's again go back to the edit mode. Okay, here you can see here update number of conductors and rods optimization. If you check this box over here, click OK. Now you can get okay. Now again optimized conductors and rods 374. Now close. You can see this is changed now. So the number of ground conductors and rods is now changed as per the requirement. So this is calculated by ETAP software, and let's again finally run the ground grid calculation over here. Now you can see there is no alarm or warnings. Now calculated touch voltage is less than the tolerable limit, and step voltage is also less than the tolerable limit. Let's close this one. Okay, so with the help of ETAP software as per IEEE80 standard, we can calculate the earth grid design.